Hi all, welcome to new class. Today's class is the continuation of conversion of flip-flops. Let us study about the SR flip-flop to D flip-flop conversion. So here D flip-flop is the required flip-flop and that input is given to a combinational circuit and whose output is given to the actual flip-flop. Here actual flip-flop is SR flip-flop and this SR flip-flop's output is the required flip-flop's output. So let us write the truth table. Truth table with the inputs D and Qn. D and Qn, where Qn is the present state of the flip-flop and Qn plus 1 is the next state to be obtained. So first one D input, then outputs Qn and Qn plus 1, then SR inputs, that is S and R. So here the possible combinations with D and Qn are 4, that is 0 0, 0 1, 1 0 and 1 1. So in the case of D flip-flop, while giving 0 input to D flip-flop, the output will be 0. Here also while giving 0 to D input, the output, that is the next state to be obtained, is 0. That is, it will not depend upon the present state or previous state. Then while giving 1 to D input, then we will get output as 1. Here also while giving 1, the output is 1. Now we have to write the SR input depending on this Qn and Qn plus 1. So this is the next state to be obtained, that is 0. So for S and R inputs, to obtain 0, what are the combinations for inputs SR? That is, to obtain 0 as the output, the SR combinations are 0 and 1. And here while checking these two outputs, there is no change. No change means SR inputs are 0 0. So here we get 0 and don't care. Don't care means either 0 or 1. So we can write 0 don't care. Next is the output is 0. 0 is obtained when S and R are 0 and 1. And here these are 1 and 0. So we can write 0 1 here. Next is 1. To obtain 1, the SR inputs are 1 and 0. And here this is 0. So we can write 1 0 here. Next is 1. To obtain 1 as the output, the SR inputs are 1 and 0. And here this is also 1, that is no change. To obtain no change condition, SR inputs are 0 0. So here we can write don't care 0. Next we have to draw the K map with inputs with variables d and qn. There are four possible combinations, so we have to draw two variable k map with variables d and qn. This is 0 0 0 and 1. Here also 0 and 1, 0 1 2 and 3. While designing the S input, we get 0 0 then 1 1 and don't care. So here these two squares we can combine, and that is equal to D. Next we have to design R. Again a two variable K map we have to draw with inputs D and Qn. 0 1 0 1, here 0 1 2 and 3, and here don't care, then 1 0 0. So here also we can combine these two squares, and here it is the design for R. R is equal to, this is D bar. So here S equal to D and R is equal to D bar. Now we can draw the logic diagram. So this is the actual flip-flop. So here actual flip-flop is SR and clock. Then QN and QN bar are the outputs. Here S equal to D. So this is the external input or required flip-flop input D. So S equal to D we can draw like this. Next is R equal to D bar. That is, here there is one inverter. R equal to D bar. So this is the logic diagram for SR flip-flop to D flip-flop conversion. Next is D flip-flop to SR flip-flop conversion. So here SR flip-flop is the required flip-flop, and that input will be given to a combinational circuit, and whose outputs are given to the actual flip-flop. So here actual flip-flop is D flip-flop. So we have to write the truth table with inputs SR, then QN plus 1 and D. So SR inputs SR, then outputs are Qn, where Qn is the present state and Qn plus 1 is the next state to be obtained, then D input. And while considering SR and Qn, there will be 8 possible combinations: 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1. Next is 1 1 0 and 1 1 1. And in SR, 1 1 is not valid, so no need to write that. But while considering the K map for D, we have to put down cares for that combinations, that is 1 1 0 and 1 1 1. We have to put a down care for K map realization of D. So next state, that is the next state to be obtained, we have to calculate. For SR inputs 0 0, the output will be no change, that is here 0. Next is 0 0 again, that is no change. No change means here it is 1. So here also 1. Next input is 0 and 1. For 0 and 1 it is reset. Here also 0 and 1, that is reset condition, that is it will not depend upon the present state. Next is 1 0. 1 0 to SR input means the output is set. Here also 1 0, the output is set. Now the D input. For this next state we have to calculate the D input. To obtain the output 0, what will be the D input? It will be 0. Next is 1. To obtain 1, the D input will be 1. So here also to obtain 0 as the output, the D input will be 0. Here also to obtain 0, D input will be 0. And here to obtain 1, the D input will be 1. And here also to obtain 1 as the output, the D input will be 1. Now we can realize using the K map. So this is, there are 8 combinations. So we have to draw a 3 variable K map. So draw a 3 variable K map with 8 combinations. Inputs are S, R, Q, N. S, R, Q, N. 0 0 0 1 1 1 1 0 0 and 1 here. Here 0 1 2 3, then 4 5 6 and 7. The D input is 0, then 1 0 0, then 1 1 1 1. 6 and 7 we have to put here down pairs. And here these 4 squares we can combine. Also these 2 squares we can combine. So this is the realization for D, and D is equal to, for these 4 squares we get S. S plus, and for these 2 squares it is R bar into Qn. Now we can draw the logic diagram. That is D flip flop is the, this is D to SR flip flop conversion. So D flip flop is the actual flip flop. So draw the actual flip flop, that is D. D flip flop, then Qn and Qn bar are the outputs, and D is equal to S plus R bar Qn. So S and R are the required flip flop inputs. So S plus R bar Qn. So there is an OR gate and AND gate. R bar Qn, that is R bar NOT gate, then into Qn. Qn is this one. So an AND gate here. R bar into Qn plus S. So here OR gate. S plus R bar Qn is given to the D input. So this is the logic diagram for the conversion of D flip-flop to SR flip-flop. Next is JK flip-flop to T flip-flop conversion. So here T flip-flop is the required flip-flop and there will be a combinational circuit and then the actual flip-flop, that is JK flip-flop. So we have to write the truth table with T, Qn plus 1 and then JK. So T input, then outputs Qn and Qn plus 1, then JK inputs J and K. And here T and Qn makes 4 combinations, that is 0 0, 0 1, 1 0 and 1 1. So for these combinations we have to find the next state to be obtained, that is Qn plus 1. For T input 0, the output will be no change, that is here this is 0, so no change. Then for T input again 0, output will be no change, that is here it is 1, so no change means here also 1. Then for T input 1, the output toggles. Toggles means what was the present output 0, that means it changes to 1. Here also for T input 1, the output toggles, that is 1 changes to 0. Next we have to find the JK inputs for the required output, that is for this 0, the JK output. To obtain 0, the JK inputs are 0 and 1. For 0 1, the output will be 0 and here this is also 0, that is no change. To get no change condition, the JK inputs are 0 0, that is here we get 0 don't care, 0 and don't care. Then to get 1, the output 1, the JK input are 1 and 0 and this is also no change condition. To obtain no change condition, the inputs are 0 0. So here we get don't care 0, don't care 0. And next is 1, the output to be obtained is 1. To obtain 1, the JK inputs are 1 and 0 and this is changing. So in changing condition, the changing condition in JK is toggling condition, that is while applying 1 1 inputs to JK, the output toggles. So this is 1 and don't care, 1 don't care. And here this is 0. To obtain 0 as the output, the JK inputs are 0 1 and here also toggling condition, that is 1 1. So we get don't care 1, don't care 1. Now we have to design JK using K-map. So here the variables are T and Qn. So two variable K-map we have to draw. Two variable K-map with the variables T and Qn. So J and K we have to get in terms of T and Qn. So here 0 1 0 1 0 1 2 and 3, and for J 0, then don't care, then 1, don't care. And these two squares we can combine, and that is equal to t. So we get a j equal to t. Next we have to find the value for k in terms of t and qn. Again draw a two variable k map with variables t and qn. 0 1 0 1 here, 0 1 2 3, and for k don't care, 0, then don't care, and 1. So here these two squares we can combine, and k is equal to t. So here we get j equal to t and k equal to t. Now we can draw the logic diagram. So first of all, draw the actual flip-flop. So actual flip-flop is JK flip-flop. So draw the JK flip-flop. Then QN and QN bar are the outputs. And here J equal to T and K equal to T. So T is the external input. That is the required input. So T equal to J and K. So this is the logic diagram. Logic diagram for the JK flip-flop to T flip-flop conversion. Thank you for watching the class. If you like the classes, please like, share with your friends and subscribe my channel.